Hello students, multivariable calculus, total differential coefficient. Today we discuss about one example problem. If u is equal to sin inverse of x minus y, where x is equal to 3t, y is equal to 4t cube, y is equal to 4t cube, then prove that du by dt is equal to 3 by square root of 1 minus t square. So now solution. Here u is a function of xy and xy are the functions of t. So you have to use total differential coefficient. U is a function of xy and they are ending with only one variable, that is t, single variable t, small t. So now dou u by dou x, dou u by dou y, since u is a function of two variables. Now dx by dt, dy by dt. Like multiplying first two terms and also last two terms and adding, we get du by dt. Therefore du by dt is equal to dou u by dou x into dx by dt plus dou u by dou y into dy by dt. Now take this is equation number 1. Now finding all these terms, we get, after substituting in equation 1, dou u by dou x is equal to dou by dou x of u. What is u given here? Sin inverse of x minus y. Now dou by dou x of sin inverse x is, assume this term as x, 1 by square root of 1 minus x minus y whole square. And now again we have to differentiate the assumed term, that is dou by dou x of x. Now this is equal to 1 by square root of 1 minus x minus y whole square into dou by dou x of x is 1, dou by dou x of y is 0, since y is constant. Therefore we get 1 by square root of 1 minus of x minus y whole square. And now we have to find the next term, that is dou u by dou y. Dou u by dou y is equal to dou by dou y of u. What is u here? Sin inverse of x minus y. Again sin inverse of x minus y is 1 by square root of 1 minus x minus y whole square. Again differentiating x minus y with respect to y. Dou by dou y of x minus y. So now we get 1 by square root of 1 minus x minus y whole square into minus 1, because x is constant we get 0, 0 minus 1 minus 1. So minus 1 by square root of 1 minus of x minus y whole square. This is dou u by dou y. Now we have to find dx by dt. This is ordinary differentiation. D by dt of x is given in the question is 3t. Substituting 3t here, differentiating with respect to t, we get d by dt of t is 1, that is equal to 3. Now the next term is dy by dt is equal to d by dt of y is here 4t cube. So now 4 is constant, d by dt of t cube is 3t square. We get 12t square. Now substituting all these values in equation number 1, we get du by dt. First equation implies du by dt is equal to dou u by dou x is 1 by square root of 1 minus of x minus y whole square into dx by dt is 3. Substituting 3 here, plus dou u by dou y is minus 1 by square root of 1 minus of x minus y whole square into dy by dt is 12t square. Now this is equal to, here the denominator is same, we get in the numerator 3 minus 12t square whole divided by square root of 1 minus x minus y whole square. Now taking 3 common in the numerator, we get 3 into 1 minus 4t square by square root of 1 minus Substituting x is equal to 3t minus y is equal to 4t cube. Since xy are given in the question, so you have to substitute xy values here in terms of t. Now that is equal to 3 into 1 minus 4t square by square root of, expanding in the form of a minus b whole square, we get 3t square is 9t square plus 4t cube whole square is 16t power 6 minus 2ab, that is 2 into 3t into 4t cube, we get 24t power 4. Now this is equal to, so that is equal to, we get 3 into 1 minus 4t square by square root of, multiplying with minus here, 1 minus 9t square plus into minus, we get minus 16t power 6 minus of minus plus 24t power 4. Now write this one in the form of, therefore du by dt is equal to, again I am writing the last term, 3 into 1 minus 4t square by square root of 1 minus 9t square minus 16t power 6 plus 24t power 4. Now this is equal to 3 into 1 minus 4t square by square root of 1 minus 9 into t minus 16 into t square whole cube, t power 6 can be written as t square whole cube plus 24 into t square whole square, because t power 4 can be written as t square whole square. Now put t square is equal to some k, constant k. In the numerator and denominator we get 3 into 1 minus 4k whole divided by square root of 1 minus 9k minus 16k cube plus 24k square. Now we have to find the factors for the denominator term, 3 into 1 minus 4k by square root of, writing, take minus common, we get 16k cube minus 24k square plus 9k minus 1. Find the factors for this denominator term by using Horner's method. 16k cube minus 24k square plus 9k minus 1. Taking coefficients by using Horner's method, we get this two factors for this equation. Horner's method. What is k cube coefficient here? 16, and k square coefficient is minus 24, k coefficient is 9, constant is minus 1. Now take k is equal to some 1, 16 plus 0 we get 16, 16 into 1 we get 16, minus 24 plus 16 we get 8, we get minus 8. Now minus 8 into 1 we get minus 8, 9 minus 8 1, 1 into 1 we get 1, 1 minus 1 we get 0. So from this we get k is equal to 1, 16k square minus 8 plus 1. K is equal to 1 can be written as k minus 1 into 16k square minus 8k plus 1. So we get two factors here. We should not take equal to 0. So now 3 into 1 minus 4k by square root of minus of k minus 1, first factor, into 16k square minus 8k plus 1. Now this is equal to 3 into 1 minus 4k by square root of, multiplying with minus here we get 1 minus k into 16k square minus 8k plus 1 can be written as 4k whole square minus 2 into 4k into 1 plus 1 square. That means a minus b whole square form 3 into 1 minus 4k by square root of 1 minus k into, so this one can be written as 4k minus 1 whole square. 4k is a, 1 is b here. Now we get 3 into 1 minus 4k by square root of 1 minus k, square root of 1 minus k into square root of 4k minus 1 whole square. Square root gets cancelled. Square root gets cancelled here. So 3 into 1 minus 4k by square root of 1 minus k into, take minus common before cancelling, we get 1 minus 4k whole square, square root cancel. Then 3 into 1 minus 4k by square root of 1 minus k into square root of, 1 minus 4k, 4k cancel, 1 minus 4k gets cancelled, we get 3 by root 1 minus k. So 3 by root 1 minus t square, since k is equal to t square. Hence proved. Like this we have to prove this problem, that is du by dt, total differential coefficient. Thanks for watching.